Hello everyone and welcome to my video. My name is Mustafa Alayawat and my final project is Dancing Light. So what is Dancing Lights? You may have seen Christmas tree lights, Halloween decoration lights or disco lights where the lights turned on and off according to the beats or the rhythm of the music, which I think is really cool. These lights uses a microphone to detect sound and lights turns on and off according to the length and pitch of the music beats or the rhythm. These are designed to pick the high intensity sound um, like bass sound. So why I choose this project? I think this project looks cool. The lights turn on and off, and also it's fun to watch. I can have this device on my desk or somewhere with me and just enjoy watching the lights turn on and off. And also, it's fun to build this project. I think it's very interesting to build this project. Um, and This project can be used in different applications where, for example, we can use this to detect a problem in the machines where we have like the microphone uh, in the machine, and when there is a bad sound, uh, uh, this device can detect that noise or a bad sound. Here are the electronic components for this project. I'm going to use a C945 transistor, a mic, a 47 kilo ohms resistor, 5 millimeters LED, and 6 volt DC battery, a circuit board. Most of these components are available in the lab. Here are the circuit diagram, and the left is the original circuit and in the right is my circuit that I will be using this in this project. I use this circuit to start and see how this device will work. Then I designed my final circuit, which uh, which is this. I just added the components in parallel. I just add the transistor and the extra components in parallel. So how this device work or how this thing work? The mic picks up the sound signal and converts it into a voltage signal, and the signals go to the base channel in the transistor, which opens the channel between the C and E, the collector and emitter. So more current flow through the circuit, and the lights will turn on. When there is no sound, there will be no signal going to the base and the lights will be off. After I finished the diagram, I started by building the circuit on the solderless breadboard to see how this device will work and figure out the wiring. So in this step, I struggle a lot to figure out how the wiring is gonna go, and also I made mistakes where the device didn't work first time, so I had to like rebuild it a couple of times. After I finished from the uh, like placing the components um, and I figure out the wiring, I start soldering the components on a circuit board. And also, soldering was also challenging, and it wasn't easy. It took me a little bit longer than I thought, but I practiced a lot and I learned a lot through this. Also, when I finished soldering the device, I thought I can add an extra switch just to turn the things off so I can save some battery. So after I finished my device, I used the box to hold my phone and also to fasten the device inside the box and to have the microphone close to the mic to my phone speaker so I can have like good result. And I used hot glue and foam board to to have the phone mount, and it seems like it's working. So here's my device when it's running. And pay attention when I change the volume and also when I change the frequency. Now, we fell in love as the leaves turn brown, and we could be together, baby, as long as skies are blue. Now, as the leaves turn brown, and we could be together, baby, as long as skies are blue. So we see in the video when I turn the volume up, the lights will turn brighter, and also when I change the frequency, the lights will turn brighter with the higher frequency, more than when it's a low frequency, because we have like higher tone. I used this app called Tone Generator. It's to provide a constant tone, so and also you can control the frequency and the volume of the tone. So here is the result in table 1. Um, we have the voltages and the volume for multiple volumes for the voltages across the LED and the brightness of the LED from different volume. And also in table 2 we have the current going through the transistor channels when the sound is off and when the sound is on. So like we have when the sound is on, usually we have a current going through the base channel, and we can have more current in the collector and also the emitter. Um, Definitely, this project allowed me to practice what I learned through this semester or in this class. Um, I used the resistors, transistors, LEDs, and these all the electronic component we worked with and learned about in this course. I feel I learned so much about how mics work, and also I practice my soldering a lot, and I feel more um, confidence about that. Thank you for listening.